In this video, I'm going to go over the process called completing the square. Now here we see a binomial that we want to square. And there is a recipe for that. You take the first term and square it. You multiply these two terms together and get 2x, a positive 2x, and then you double it. So that will give you a positive 4x. Then you take this last term and square that, and that gives you a 4. Now you now have a trinomial that's called a perfect square trinomial, and it's in the form of the quadratic expression x squared plus bx plus c, where here the coefficient of x squared is just a 1 that we don't write. And then we have our b term is just the positive 4. And the c term is also a positive 4. So, in completing the square, we want to have a trinomial that is a perfect square trinomial that would then factor into a binomial that you would square. So let's look at an example. So suppose we have x squared plus 6x, and we're looking for what term would be our c term. And by the way, the c term is always a perfect square. Well, a technique for that is, you know it's going to be a binomial when you finish, so you set up a parenthesis that will be squared, and you're looking at x squared. What were the factors that gave you an x squared from this form? And the answer is x. Now the middle sign is going to be the same as what's there, so that plus just comes down. And then we did what to these? Well, we multiplied them together and then doubled it to get our b term, which is this b term here, the 4. So if we have 6, we got the 6 by doubling something. So how do we undo that? Well, if we doubled it, then we, in a sense, take 1/2 of it or divide by 2. And the technique would be 1/2 of 6, our b term. So 1/2 of 6 is 3. Now that we know the second member of our binomial, what did we do to get this term? Well, we said we squared this term. So we square the 3 and get a 9. We now have a perfect square trinomial. Almost ran out of room. Now, that's the basic process of completing the square. Now we're going to use it in a more challenging example. Now in this example we see we have a start, and I've changed the letter to A. We have a start of a quadratic expression, but again we're missing our C term. So we want to take this and use the technique of completing the square. So again, we'd put our parenthesis that we will square. We're going to take a squared and take the a from it, because a squared becomes a squared, as we did here. We're going to use the plus sign. Now our b term here is 3. So again, the technique is you're going to take half of 3 and you get 3/2. Now that we know the second part of our binomial that we're going to square, to get our c term we have to square this, and that will give us 9/4. So our quadratic expression in standard form will be a squared plus 3a plus 9/4. Now if we factor that, we get this. And we have done so through the process of completing the square. Now, where do we use this process? Well, we use the process of completing the square if we have an equation that's in standard form, a quadratic equation, and we're asked to solve it by completing the square. So there is a protocol for this, and it looks like so. Now, in order to complete the square, our a term, which is the coefficient of x squared, needs to be 1, which it is. And we have our b term and we have our c term. And we could put an a right there. A x squared plus bx plus c is the standard form for the quadratic expression, and if I put a 0 there, it makes it the standard form of the quadratic equation. So the first thing we do in completing the square is transpose our c term to the other side as a -2. We then take what's left then, and we want to find the binomial that when we square, that it makes a perfect square trinomial. So I'm going to use this line and take the 2 out of there and just put it over there also. Okay, so we said take half. Well, first the square root of this is x. The plus comes down there. And now we want to take half of 5, which is our b term. Well, that's going to be 5/2. Now, with the 5/2, we can then find what our c term will be if we square that, and we get 25/4. Now, so far we had an equation, but now adding this to this side, in order to keep it an equation, we have to add the 25/4 to the other side. Now, this is still an equation. So here, 25/4 as well. Now, we do want to subtract these terms. In order to do so, they must have a common denominator. So remember, this is in a sense 2 over 1. To make this a common denominator of 4, I have to multiply this by a 1 in the form of 4 over 4. So this now becomes a negative 8 over 4 that I will subtract and get 17 fourths. So this became a negative 8 over 4. 8 from 25 is 17. And I now have on this side, make it a little colorful, x plus 5 halves squared. So everything is equal so far. We're just manipulating a little bit and using the process of completing the square. Now we have this expression squared. Well, what do we do there? Well, we can take the square root of this side. Remember, there's a 2 there. And if we take the square root using that number, it just becomes the radicand. Now we must take the square root of the other side, and we do plus or minus that. Notice the 4 is a perfect square, so this will become plus or minus the square root of 17 over 2. Now we have an expression on this side with no exponents and this expression. To find out what x is, all we have to do is take this term, transpose it to the other side where it gets its opposite sign, and we have solved for x. Now another way to write this, of course, is x over a negative 5 plus or minus the square root of 17 all over your common denominator of 2. Okay, we went through the process of what is completing the square, and then given an example of completing the square, and then showing where this process is used to solve a quadratic equation by the process of completing the square. All right, to follow this up, we want to use that same quadratic equation in standard form, but this time we're going to use the quadratic formula. Now, to use the quadratic formula, we have to define our a term, which is 1, our b term, which is positive 5, and our c term, which is a plus 2. And we're just going to substitute into the quadratic formula. So we get x equals, now a negative b is 5, so a negative 5 plus or minus the square root. Now b squared is 5 squared, which is 25, minus 4 times a, which is 1, times c, which is 2. And all of this will be over 2 times a, which is 2 times 1, which is 2. So we then get x equals negative 5 plus or minus the square root of A negative 4 times 1 is negative 4 times 2 is negative 8. So 25 and a negative 8 is 17 all over 2. So we had done this by completing the square, and now we have used the quadratic formula, and notice our answers are exactly the same. So another method for solving quadratic equations.